All right. Okay, so last time we talked about formal languages, and also we have one notation to represent the language, which is called final automaton. And this particular type is called DFA. D is short for deterministic final automaton. So yes, we have these exercises last time. We have the description of languages, and we would like to design or define a final automaton to represent each of these languages. So maybe I can review a little bit. All right, so last time we talk about so let's first look at some of the terminologies. So we have alphabet. So what is alphabet?
It's a symbol that defines for a language. Something like
Yes,
that.
but is it a collection of elements called symbol, right?
Yes,
So
correct.
yeah, it is called a set. It is a set. So in lesson one, we also know the difference between set and sequence, right? So alphabet is a set. It is a set of elements called symbol or characters. And the set, it needs to be finite, right? And then we have strings. So what is string? Or we can say word. So what is it? It is a sequence of symbols. Okay, so you can see that alphabet is a set of symbols, but string, it is a sequence of symbols. So the order of the symbols in a string is important. So if we have different orders, we have the same symbols, but in different orders, so we can obtain different strings as well. And what do we have next? We have language. So what is a language?
A set of string.
Yes, it is a set. But the element of the language is a string. All right. So we have these three important things to yes to understand, and then we have the DFA. Okay, so for DFA we have in order to build a DFA, we have to have 5 components, right? So we have to have Q here, capital Q. And then we should have also the alphabet, transition function, start state, and set of final states. So we have to have these 5 components. So you can say that this is set of states, right? Because when we talk about DFA, we talk about a system with a lot of states. And because of the word F here, F is finite. So our system should have a finite number of states. So Q here is this is finite set. And H is alphabet, so we know already it is a set of symbols. And it is a transition function. So for transition function, the input, we have 2 inputs, right? The first input is the current state. So it is an element of Q. And the second input, it is a symbol, which is an element of alphabet. And then the output from this function is another state, or we can say that it is a new state. Yes, in another word, we can say that if the system is at a current state, let's say Q, and then it like a new symbol, a symbol arrives. Let's say symbol A arrives at the system. So we can look at the transition function to know which state the system should change to. So according to this transition function, for example, state P. So it means that if the current state is Q and it reads or the symbol A arrives, the system should change state from Q to P instead. Okay, so this is called transition function. So how many transitions that we can have? So it depends on the number of states and also the number of symbols. So let's say we have 3 states and we have 4 symbols. So how many transitions that we can have for this DFA? Anyone?
12.
Yes, 12. So from each state, we have to have a transition for each symbol. So the total number of transitions should be 3 multiplied by 4. So it is 12. Okay. And then the fourth component, it is the start state. So this is one component, one state of Q here. So we choose one state to be a start state. And then we have the last component, which is F. You can see that it is a capital letter. So for capital letter, usually they are set. Right? So this is a set, this is a set, and this is also a set. So this is a set of final states. So we choose some states from Q to be final states. We put it as a set because in DFA we can have more than one final states. Okay, but we only have one start state. And actually, it depends. In some lecture, in some textbooks, it is also possible to have multiple start states, but it is not called deterministic final automaton anymore. We call it like NFA instead, which is short for non-deterministic final automaton. Okay, so I won't go into detail into this part, but if you have already studied the course automata theory, we have talked about this already, about the different types of final automaton. Okay. All right. So now we have all the components to build a DFA. So we will talk about how can we use DFA to test if a string is accepted or is rejected by the system. So usually we have a string. So let's say W. So in order to test, to process this string, we need to read the symbol of this string one by one from left to right. Let's say the string is ABC. Okay, so we have 3 symbols in this string. So we read from left to right. It means that we read A first, and then we input A into our DFA. So we can say that the DFA should start from the start state. So usually it starts from Q0, which is the start state of the DFA. And then when it reads A, which is the first symbol in our string, it will look at the transition function to know that the current state now is Q0 and it reads A. What should be the state that it changed to? Okay, so let give an example of a transition table. Let's okay, something like this. We have 3 symbols, and then let's say that we have 3 states as well. So we have Q0, Q1, and Q2. And I just put random output here. Let's say that Q0, if the system reads A, Q0 the same, and then this one Q1, this one Q2, and this one Q0, Q0, Q1, and this one, let's say Q2, Q1, Q0, something like this. Okay, and this is our start state. So I can draw the arrow like this to say that this one is a start state. Okay, and also we can from this we can also draw a graph to represent our DFA. So maybe it is easier to look at the graph. So we have to draw circles to represent the states. So this one is Q0, Q1, and Q2. Okay, so let's say that Q2 is the final state. And then from each step, we have to have 3 transition because we have 3 symbols, right? So according to this transition function, Q0, when it reaches A, it doesn't change state, so it stays at Q0. B, it transitions to Q1. And C to Q2. Now Q0 now has all of the 3 transitions, so we can move on to Q1, A to Q0, B to Q0 as well, and then C to Q1. And for Q2, A to Q2, B to Q1, and C to Q0. Okay, so we have all of these transitions. Now we have all of the transitions. And the last part is about final state. So we have only one final state, and Q2 is the final state. So we draw double circle. All right. So let's try to process the string ABC here. So first we try with the first symbol, which is A. So Q0 with A, we can look at the graph or look at the transition table here. Q0 with A, is this still Q0? So we move on to the next symbol in our string, which is B. Okay, so Q0 with B, it now transitions to Q1. Okay, and after that, the last symbol in our string, which is C. So Q1, C, Q1. Okay, so after we have read all of the symbols in our string, this is the last state that the system is in. So we will look at this state and we ask if this state is a final state or not. Okay, so this one is not a final state. We have only one final state, which is Q2. So this is not a final state. So we can say that W, which is ABC, is rejected. It is not accepted. So for the string to be accepted by our DFA, it means that after we have read all the symbols in the string, or after we have processed the string, the last state that we arrive in should be a final state. If it is a final state, we accept. If it is not a final state, we reject. It is that simple. Okay. And then we can write something like this, the extension of the transition function, data star. So we start from Q0, and after we process the string W, we should arrive at QF. QF here belong to F. This is to say that W is a subset. All right. Okay. So now we know how to process string and how to test if a string is should be accepted or should be rejected by our DFA. And then what is the language? Because we build in our exercise, we have a language. It is not a string. We have a language, which is a set of string. So when we say that a DFA represents a language, it means that it accepts all strings of that language. And it will reject other strings that are not that do not belong to the language. Okay, so it means that if we have a DFA and let's call it A, we can say that the language of A is a set of all strings such that here, when we process the string, it arrives at like the last state is final state. Okay. So any question about this review? Is it clear for everyone?
Look, like sometimes how we define all those states. Like if we have like a language with complexity or something, how can we define those states like Q0, Q1, Q? How could we know how many states that we define?
Yes. Yeah, that is a very good question because that is what we have to know in order to solve this exercise. Because right now we have a language, so we need to build a DFA to represent each of the languages. So we have to know like how many states, what is the transition function, and among the states that we have defined, that we have chosen, which one is the start state and which ones are the final states. So this is the question that we have to think about. But I can give you one tip. So we have to give some context or some meaning to the state that we define. So remember the last example about a language, a set of strings such that a string contains sequence AB. Do you remember? This is the last example. And the alphabet is, we have only two symbols, A and B. So at that time, we choose to have three states. All right, because the important point here is that we have to look for the sequence AB. So for sequence AB, we have two symbols, A and B. And because we read one symbol at a time, so it means that we have to find A first. And then after we have found A, we should look for B right after the A that we have found. Okay, so we consider three different states. So for the first state, it means that we haven't found A yet. So we give it the meaning, we give the definition to this particular state. So haven't found. So this one, let me change to red. So for this one, we give the meaning. Haven't found A. All right. And for this one, have found A. So haven't found A. When we and this one we have found A. And the last one, have found B right after we have found A. Okay. So here
Yes.
it means that we haven't found anything yet, and here it means that we have found A, and here it means that after we have found A, we have found B. We see B right away. So we have found the sequence AB, because this is what we want to look for, the sequence AB. Okay. So yes, to answer to your question, in order to know how many states should we have to define. We have to try to look for the meaning of each state that we define.
So mostly like for first part, we just find the small solution, and then how about if like a long string or something, and then we take that small solution, put it in that long string. Like for example, they want to find a last, like second last element or something, and then
Yes.
we have to find.
Or another way, in order to define how many states, is that how many possibility that we can have. Because a state is also a possibility. So let's say that if we have 4 possibility that we can have, so maybe we can define 4 states to represent each of the case or each of the possibility. Okay.
But when I define for last homework, sometimes I found like accept some other string that should not be accepted. I have no idea.
Okay. So let's try to look at the exercises together. So let's start with the first one. So this is similar to the example that we have in our lecture, but this time AB should be at the end of the string. All right. So probably we can use the same context here, because the important thing is the still sequence AB. So here I can change here to okay, ends in AB. Okay, so let's start from this state, and let's call it Q0, this one Q1, and this one Q2. Yeah. So now we are at Q0, so it means that we haven't found anything yet. So when we so now when the input is symbol A, it means that we have found A, right? So we should change state from Q0 to Q1. But if it is B, we still haven't found A. So it should we should still stay at the Q0. Okay, so this one is very similar to the previous example. Now we have already two states, two transitions, sorry. So let's move on to Q1. For Q1, it is a state to represent a case that we have found A already. So if we found A again, we should still we should still be looking for B, right? So it is the same state. So when we with A, it should still be at Q1. We do not change state because we are still looking for B. And when it reaches B, so now we have found A. We have found we see B right after we have found A. So we see the whole sequence AB here. So which state that represents the case where we have seen the full sequence. So it is Q2, right? So when here when we are at Q1 and symbol B arrives, we should change state from Q1 to Q2. Okay, this is also the same as the previous example, but the last one here, it should be different because the last example, it say that it contains. So after we have seen A, B, it means that no matter how many symbols that we add at the end of this sequence, we still have to accept the string because it already contains the sequence AB. But for this case, the string should end in AB, should end in AB. So it means that after we have found sequence AB, if we add like, let's say A, so it will something like A, B, and then A. So it doesn't end in AB anymore, right? So the string can still be rejected. So that is why we have to analyze further for Q2. So Q2, when it now Q2 we have AB, and when we add A, so what state should we be in now?
Q1.
Yes, Q1, because right now we need one more B so that it ends in AB again, so that we can accept it. So this is it is Q1 that is the state that represents this case. So we will change to Q1. And what about B? It means the AB and then B. So now for it to be accepted again, we have to have A and then B right after A. Okay, so it is Q0. So we change it to Q0. Okay, so that is it now. So Q0, it is our start state because at the beginning we haven't read any symbol. So it is we haven't found anything. So it is the start state. And Q2, it is the final state. Okay, so this is exercise number 1. All right. Any question?
Look cool. May I ask you one question? How can we know that we can reuse state like ខ្ញុំចង់សួរថាយើងអាចមើលមិនដឹងថាអាចកាត់ state បានអត់លោកគ្រូឧទាហរណ៍ string ហ្នឹង AB អញ្ចឹងតែយើងមានវិធីណាដើម្បីមើលថាយើងអាចបន្ថយ state វាបានអត់
Yeah. So your question is how can we reduce the number of states in our DFA? So actually, yeah, I forgot to mention as well that for one language we can have a lot of DFA, a lot of different DFAs to represent it. So the most efficient one is the one that has the least number of states. So yeah, actually we have one algorithm you have already learned as well in the course automata theory. It is to minimize the DFA. So by applying this algorithm, we will obtain a new equivalent DFA that has the as little number of states as possible. Do I answer your question?
បានលោកគ្រូអញ្ចឹងយើងតើតែយើងសិក្សាលើ algorithm ហ្នឹងសិនណាលោកគ្រូយើងមិនមែនថាយើងមើលនឹងផ្នែកទៅអាចនឹងឃើញព្រោះនេះយើងមើលទៅវាចាប់ផ្ដើមពីគុយ0អញ្ចឹងតិចNAB អញ្ចឹងវាអាចនឹងមាន3 state អញ្ចឹងលោកគ្រូតែយើងចង់ព្រមវាឲ្យទៅជា2 state អញ្ចឹងយើងអាចថាយើងអាចមើលអញ្ចឹងអត់បានទេមែនលោកគ្រូតើតែយើងប្រើalgorithm code ដល់លោកគ្រូនិយាយថាមាន algorithm ដើម្បី check វា
ហ្នឹងហើយពីព្រោះអីតាមពិតដើម្បីដោះស្រាយអា problem ហ្នឹងគឺយើងអាចមាន different thinking ឧទាហរណ៍ថាឥឡូវយើងមិនទៅយើងគិតថា 3 state យើងគិតអញ្ចឹងយើងគិតថា state នេះតំណាងឲ្យចេះ state នេះតំណាងឲ្យចេះ state នេះតំណាងឲ្យចេះពេលអ្នកផ្សេងគេអាចគិតផ្សេងវិញគេគិតថាគេថា the meaning of each state ហ្នឹងវា different ទៅតាមហ្នឹងវិញណាអញ្ចឹងបើគេ define អា different ហ្នឹងបើ meaning ផ្សេងអញ្ចឹងអាចំនួន state ហ្នឹងវាអាចដូរដែរជាជួនកាលទៅយើងអត់ដឹងថាអា way of thinking ណាមួយដែលវាល្អហើយមិនចឹងអញ្ចឹងតើតាដើម្បីឲ្យច្បាស់តើតា apply algorithm minimization ហ្នឹង
បាទលោកគ្រូអរគុណច្រើនលោកគ្រូ
បាទអញ្ចឹង if you want to know more about because I don't think it is in the scope of this lesson so if you want to know more about the minimization algorithm for DFA you can try to do research or you can just look back at the automata theory course. We have already learned about this algorithm. All right, so next, number 2. Now, it is still similar to the previous examples. We still focus on the sequence AB, but right now, AB should be the start of the string. Okay. So what should we do? So let's say that we have 3 states again. Q1 and Q2. Okay, so here I can write something very quick. So Q0, we start with Q0. So we do not have any symbol yet. So when it is A, it should change to Q1, and then B, it should change to Q2. So this is our final state. So now it means that we have started with AB. So any symbols that we add right after this sequence, our string is still accepted. So here it is A, B. All right. So now if we look at our DFA, we have already 4 transitions. But because we have 3 states, so actually we need to have 6 transition, right? So from Q0, we only have a transition with A. So what is the transition with B? So like at the beginning of the string, it starts with B. It starts with B.
Then the string is not acceptable.
Yes, so it should be rejected right there, right? Because it starts with B, it cannot start. So it means that it doesn't satisfy our condition. In order to start with sequence AB, the first symbol should be A, but now the first symbol is B. So how can we reject it right from the start like this?
We make a new state that rejects the string.
Yes, that is correct. So we can have one more state, and the definition of this state is just to reject strings. Okay, let's call it Q3. But this is just to reject string. So from Q0, if it sees B, it will go to Q3 so that it can reject string. It can reject this string. The same thing when we start with A and then A again. So no matter how many symbols that we add to this string, it still is rejected. It will still be rejected. So the same thing here, it should move to Q3. And what is the transition from Q3? So for here, we want that no matter how many symbols that we add to this string, it will still be rejected. So it cannot move to Q2. So we can use a loop like this. Okay, so if it arrives at Q3, it cannot leave Q3. It will stay at Q3 forever. Okay, so this is our start statement. So that's it. This is exercise number 2. Okay.
លោកគ្រូកន្លែងហ្នឹងបើសិនយើងឲ្យវា loop តែនៅកន្លែង Q0 ហើយនិង Q1 ទៅបានដែរវាអត់ទៅដល់ Q3 ដូច Q2 ដូចគ្នាឧទាហរណ៍ដូចចាប់ផ្ដើមដំបូង B យើងឲ្យវានៅ0ដល់ពេលហ្នឹងហើយអញ្ចឹងវានៅ0អញ្ចឹងវាអត់ទៅដល់ Q2 អញ្ចឹងនៅតែ acceptable ដែរតែយើងអត់ចាំបាច់ប្រើ Q3 អញ្ចឹងបានអត់
Yeah, actually if we do it like this, the string BAB AA, it is accepted as well, but it should not be accepted.
Okay.
Yes, because it is something like this, right? Q0 and then B, it loops with itself, and then A, and then blah, blah, blah. So here you can see that B, Q0, and then AB here, it will move to Q2. And the last 2A here, it will stay at Q2 again. So this string will be accepted. But it should not be accepted. It should be rejected because it doesn't start with the AV. So for the DFA to represent our language, it means that it accepts all the string belonging to that language, and it's also reject all the string that do not belong to that language. Okay, so we have to satisfy these two conditions. If we satisfy only one condition, so maybe we can just use this one. Okay, this one. Okay, so this DFA only one state. You can see that it accepts all strings. So this is to represent H star, all string. All right. So maybe it can be used for all types of language, but actually it is not, because we have to satisfy like one more condition, which is if the string does not belong to the language, it should be rejected by our DFA. Okay. All right. So is it okay for number 1 and number 2? Sorry. Number 1 and number 2, it is okay, right?
Okay.
So we can move on to number 3. So number 3, it is a to the power of n, and then we have like the final symbol, it should be B. So A, we can have how many? We can have how many A at the beginning of the string? N is greater or equal to 0. So it can be 0 as well. So if n is 0, it means that we don't have to have a at the beginning. We can just have b. So if our string is b, it should be accepted as well. If w is equal to just b, it should be accepted as well. And then it can be a one time, and then b, a can be many, like no matter how many times, it is okay as well, as long as the last symbol is b. So how many states should we have for this one?
I would say 4.
I think it should be 3 state.
Okay, so we have 4 and we have 3. So 4, what is the meaning of each state if we have 4? So now our exercise number 3, it is a set of string. Maybe I can write like this instead. Okay, a to the power of n, and then the last symbol should be b, and n is greater or equal to 0. And the alphabet, we have only 2 symbols, a and b. Okay, so yes, you say that we need 4 states. So we have to give some meaning to each state. So what is the meaning of the first state? So this is the first one, this is the second one, the third one, and the fourth one. So let's say this one Q0, Q1, Q2, and Q3.
So the first state is for the we have to get the A for going to the Q1 because it cannot start with B.
Okay, so it means that this one to represent, let me change the color. So the first one to represent a to the power of n, right? When we see all A's. And what about the second state?
Wait, I'm not sure about what you draw, but what I mean is for going to Q1, you need to have A, and then to Q1 to Q2, you need to have B. And as long as we have A, we stay in Q1. And if the beginning if the letter is B, so we go to Q3 because it is not the final state.
Okay, so A, this one, the transition from Q0 to Q1, it is with A, right?
Yes.
Okay. What about B? Q0 when it is B?
For me, it go to Q3 because we don't want to start with B.
But it is possible to start with B. Like
Yes, it is, but
if
only
we
if
have
it's...
only B, it is also a subject. Because here you can see that n can be 0 as well.
Yes, but it cannot be B A power n B. I mean, we cannot start with B and then A.
Okay, so let's try your complete DFA. So B, it goes right here. So now move to Q1. When it reaches A, it will go where?
If it's A, it's still in Q1.
Okay, and if it is B?
We go to Q2.
Q2, okay. And Q2 is the final state, right?
Yeah, but okay, something happens because there you can have B alone. With my DFA, we can't have B alone. But
Yes, I think for your idea, this one is a final state, and this one is to reject string, right? Q3.
yes.
That means that after here, if it should be a B right here. And here it should be AB right here. And this is the start state. Okay.
លោកគ្រូចឹងអា
Yes.
ហ្នឹងឯងអង្គុយ3ត្រូវ final state ដែរលោកគ្រូ
Yes. Q3 here, it is for rejecting string. So it is not. So it is. You can see that it satisfies all of the condition except one, which is the W is
លោកគ្រូ
equal
ចុះ
to
កន្លែង
B.
ហ្នឹងគេ n 0បានហើយលោកគ្រូចឹងបើសិនជា n 0 a អត់មានយើងមក b យកហ្មងវាមិនដល់ final state
ហ្នឹងហើយនេះខ្ញុំអត់តោះថាប់ត្រូវទេខ្ញុំគ្រាន់តែ follow តាម idea របស់គាត់ណា Okay, so let's say that if it is A and then B, it is should be a subset. So according to this DFA, A and then B, it arrives at Q2. It is correct. So let's say A 5 times and then B. So it is correct as well. But if we have only one B without any A, it will arrive at Q3, right? So this one is not correct. So this one condition is not fulfilled.
Can we have two final states?
Yes, we can have more than one final states.
Then maybe we can add another final state, which is if we have only B, then it's the B. The word is B.
Okay, so maybe like this. So this is not a rejecting state anymore. So we have to have one more state as a rejecting state, right? So maybe Q4, it is a rejecting state. And then right here, AB, and then here AB. And here it is AB. Okay.
Yes.
Yeah, it is correct. But we can find like another DFA with less states than this. We can have like three states, and we can build a DFA, an equivalent DFA with just only three states. Someone said that you can have three states. Can you show me? Can you state your ideas? Okay, so we have three states: Q0, Q1, and then Q2. And Q1 can be the final state. So Q0 represents the case where we see only the sequence of A. So when it reaches A, it is still a sequence of A. So it loops to itself. Okay. So and Q1, because it is a final state, it means that we have seen 1B right after a sequence of A. Okay, so here I give the definition to each state. So this is sequence of A, and this is a B right after the sequence of A. So you can see that this is the definition of our language. So this is the final state. So it means that here Q0, when it reaches a B, it should move to Q1. Okay, so here when we have a 1B right after the sequence of A, so if we add more symbols to the right side of this string, it should be rejected, right? Because it does not satisfy the condition of our language anymore. So that is why we have Q2 here to be our rejecting state. So A or B, it should be here. And here, A or B, it should stay at Q2. Okay, so you can see that if W is equal just only with one B, it will go from Q0 to Q1, which is the final state. So both of these DFA are correct. Just that the second one, we have only three states, so it is more efficient. Okay, is it clear for everyone?
Yes, I would like to know something. For the DFA, is the efficiency important? Because, for example, what's the difference between 3-state and, I mean, I know it's faster, but is it really important, the efficiency for DFA? Thank you.
Yes, let's say that because here just 3 and 5, so it doesn't matter a lot. But because when we talk about DFA, we have to implement it into a program, right? So, for example, if we have more steps, we require more like execution time, running time, and also we need more memory because we need like memory to store all of the states, right?
Yes.
So yes, when our DFA is like become bigger and bigger, become more complex, so the number of states can be important as well. So we want to be as small as possible for the number of states. So it's just like you said. You said when we talk about the efficiency, we talk about less memory and less running time. All right. So it is okay for number 3. So now number 4. So for number 4, yes, number 1, number 2, number 3, they are infinite set. The language are infinite sets. So for number 4, it is a finite set. You can see that we have only 4 strings in our language. And now for our alphabet, we have 3 symbols. So what can we do here?
So I have 5 states.
Okay, so let's copy it here. So ABA, ABC, ABC, BC and B. This is our language. So for this one, yeah, we can do something very simple. Let's look at these 2 strings. You can see that they both start with AB, all right? So probably we can draw something like this. So A and then B, right? And after that, it can be either A or C for the last symbol in this sequence. So maybe this is our final state. And then here it can be either A or C. So just this, so now we have used 4 states already, and it covers these 2 strings. So we still have B, C, and B. So what can we do here? Let's look at B. So we have here is our final state, right? So we can just move from here to here and with B. So now we cover this one as well. So only BC left. So what can we do about BC?
See the same state. Wait, no.
Should we add one more state? Or can we just add a transition?
But we need to
Can we do
reject
something? Yes, can we do something like this?
No, teacher, because there is an A.
Yeah, if you do something like this, you can see that yes, it now accepts BC, but it also accepts BA because from this state to this state, we have one more transition by A. Okay,
I
so
simply add one more state.
yeah, so the safest, the most safe way in order to cover BC, we can just add one more state here.
And also, maybe we remove the transition from Q0 to the final B and then add the new state as a finished state.
So sorry, can you repeat again?
We add another state and then we remove the transition between Q0 and the Q4, Q3, and then the next state that we add is a final state from Q0
okay,
to
let me put in the number first. So Q0, Q1, Q2, and Q3.
Yeah, because like if we add another state, we're gonna have to transition from Q0 to that through symbol B, but we already have a transition from Q0 with symbol B. So
yes.
maybe we remove that and put the new state as a final state as well.
Okay, so we remove this transition and then we put in a new state. Let's call it Q4. And then this one is a final state as well, right?
Yes.
And then this one is B and this one is C. All right. So now we have 5 states and we have covered all of the strings, all of the 4 strings. So you can see that it is not complete yet because we have 3 symbols and we have 5 states. So we have to have 15 transition, right? For example, Q0, we don't have a transition with C yet. So for other transitions, what should we do? So we should have one more state as a rejecting state, right? So let's call it Q5. And for the rest of the transition that we haven't had yet, we will point to Q5 so that the string can be rejected. So this one, it is, we still have C. This one, we have already B, so we still have A and C. For this one, AC, so we still have B. This one, nothing, so all A, B, and C should point here. This one already C, so we still have A and B, right? And for the last state, Q5, it should also loop to itself. So A, B, and C. Okay, so this is our final DFA. So we have 6 states in total. Okay, so you can see that for this language, it is very simple with only 4 strings, but we require like a much more complex DFA if we compare to like the previous example. Yes, what is the question?
ចឹងលោកគ្រូមានថារបស់ដែលសល់ transaction ហ្នឹងយើង should បង្កើត new state ដើម្បី reject អានឹងចោលលោកគ្រូ
Yes.
Okay.
Because our language we have only 4 strings, so our DFA should accept only these 4 strings, and the rest of the strings, not these 4. Rejecting state.
លោកគ្រូចឹងទោះបីជា final ឬមួយក៏ infinite ហ្នឹងក៏យើងត្រូវតែមាន reject string មួយដែរមែនចឹងលោកគ្រូ
It depends to yeah, actually it depends on the language whether we have to have a rejecting state or not. Like you can see the exercise number 1 here, we don't have to have a rejecting state. When we talk about rejecting state, it means that when we arrive at that state, no matter how many symbols that we add to the string, we cannot accept the string.
លោកគ្រូចុះលំហាត់ទី 4 ហ្នឹងបើយើងអត់មាន input string ផ្សេងក្រៅពីអា 4 ហ្នឹងផងយើងត្រូវការដាក់ reject string ទៅអីលោកគ្រូ ព្រោះ string ដែលយើង import មានតែ4ហ្នឹងដែល start ពី A ហើយនិង B ហ្នឹងអញ្ចឹងយើងបាច់ត្រូវបង្កើត C ទៅ reject C ទៅអីលោកគ្រូហ្នឹង
ដោយសារហ្នឹងវាជា DFA ចាប់បានន័យថាពេលដែលយើងបង្កើត DFA មិនមែនបានន័យថាយើងបង្កើតដើម្បីតែ sub string របស់ language របស់យើងទេយើងបង្កើតមកដើម្បីឲ្យ sub គ្រប់ string របស់ language យើងហើយយើងត្រូវបង្កើតមកដើម្បី reject គ្រប់ string ដែលមិនមែនជារបស់ language របស់យើងទៀតអាហ្នឹងបានវាជា DFA តំណាងឲ្យlanguage L របស់យើងចេះតែខ្ញុំនិយាយមកអញ្ចឹងបើសិនជាឥឡូវយើងបង្កើតមកសម្រាប់តែ sub string ដែលមាននៅក្នុង L ហ្នឹងទេតែឥឡូវយើងគ្រាន់តែអញ្ចឹងគ្រប់ language ទាំងអស់យើងបង្កើតតែ DFA មួយនេះchoose 0អានេះ final state មកហើយ AB អញ្ចឹងអាហ្នឹង4ហ្នឹងគឺវាអត់សពទាំងអស់ទៅហ្នឹងហើយអញ្ចឹង4ហ្នឹងវាអត់សពទាំងអស់ប៉ុន្តែសួរថាអាផ្សេងទៀតវាអត់សពដែរអាផ្សេងទៀតក៏វាអត់សពដែរអញ្ចឹងបានន័យថាអា DFA មួយហ្នឹងវាមិន suitable សម្រាប់ language របស់យើងទេដើម្បីវា represent language ហ្នឹងបានលុះត្រាតែ DFA ហ្នឹងវាអត់សពគ្រប់ string ទាំងអស់របស់ language ហ្នឹងប៉ុន្តែវា reject គ្រប់ string ទាំងអស់ដែលមិនមែនជារបស់ language ហ្នឹងវិញចឹងបាទយើងត្រូវមានអាហ្នឹងដើម្បី reject វាអត់មានអាហ្នឹងទេអាហ្នឹងវាអត់ complete ទី1វាអត់ complete ហើយទី2គឺវាអត់អាច reject អា string ណាដែលមិនមែនជារបស់ language Okay, so can we move on to the next one? Okay, so number 5. So now the definition of the language language number 5 is that the last element of the second last, not the last, the second last of W is 0. So how many states should you have? So it means that blah, 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 and then it should be a 0, right? And then the last one, it can be, I mean, 0, 0 or 0, 1, right? As long as the second to last element is 0. Then we are sub.
I think 3 is enough.
3?
Yes, I would say 3 too.
Okay, 3. So Q0, Q1, Q2. So Q0, what does it mean, Q0? So we have to look for 0, right? So Q0, it means that we haven't seen anything yet. So it is very similar to like the first two examples. So Q0 haven't seen anything yet, and Q1 we have seen 0, right? So it means that Q0 when it reaches 0, it should here. What about 1? Q0 1?
I think it's still in Q0.
Yes, it's still in Q0. Okay. So now, what about Q1? When it reaches 0,
it's still there. It's not going to change that.
And when it reaches 1, it moves to Q2.
Go back. No, oh why?
If it goes back, we have only 2 states.
It's maybe it's go to Q2, I think, for 1, and then the final state is Q2 and Q1.
Q2 and then Q1. And what about Q2? What is the transition from Q2? What are the two transitions from Q2?
Can we go back?
0, 0 to where?
0. I think it should be go 0. And
I don't think that works. Because that means if you have like only 1 and 0, it will accept 2. like
Yes.
just treat each 1 and 0, then it will accept, but that doesn't end with the second number as 0.
Yes. For example, 1, 1, 1, 1, and then 0. It does
We're
as well.
probably gonna need one more state to make it easier.
Yes, actually we need 4 states for this one. So the same thing I will yes. So for this one, this is the for Q1 it means that we have now we meet 0, right? So we have to have 2 more states. So Q2 and then Q3. So for Q2 it means that it meets 1 after it meets 0. Or maybe let's talk about this case for it means that it meets 0 after 0. And for this one, it will meet 1 after 0. Okay, so it means that Q1 when it reaches 0, it should move to Q2, right? Because it satisfies this condition 0 after 0. And 1 it should be here. So it is complete. Q1 now has 2 transitions with 0 and with 1. So now let's look at Q2. So it means that 0 and 0, and then we add 0 again.
It stays at Q2.
Yes,
which is
so you can see that this is when we look at the last 2 symbols, it is still 0 after 0. So it's still satisfy the condition of Q2, right? So it means that it should be at the same state. What about 1? 0, 0, 0, and then 1.
Then it moves to Q3.
Yes, it moves to Q3 because when we look at the last 2 symbols, it is 1 after 0. So this is the definition of Q3, right? So here I will move from Q2 to Q3 with 1. Now it is complete as well for Q2. Let's look at Q3. So Q3 0, 1, and then we add 0.
It moves to Q1.
Yes, because you can see that now we have only 1 0, and we still look for like the second symbol. It can either be 0 or 1. So this is Q1. This is the state that has this definition. Okay, so I will move from Q3 to Q1 with 0. And what about 1?
Q0.
Yeah. If we put 1 like this, for it to be accepted again, we have to have 0 and then like 1 more symbol, right? So what is the state that is looking for 0? It is Q0, right? So we can change this one from Q3 to Q0. Okay. 1. And this is our start state. So what is the final state, or what are the final states? Yeah. Well, what are our final states? Do we have one final state, or we have more than one final states?
We have more.
2.
We have Q2 and Q3.
Yes, you can see our condition. It can be 0, 0, or 0, 1. So this one or this one. Okay, so we have 2 final states here. Yeah. So that's it for number 5. Okay, number 6, very easy because we have seen it already. So for number 6, W contains 0, 1, 1, right? Okay. So how many states? So we can focus on this sequence. This sequence has 3 symbols. So how many states should we have?
4.
Yes, 4. Okay. So this one 0, 1, and then 1. This should be our final state, and this is our start state. So for the first one, let's say this one Q0, Q1, Q2, and Q3. Okay, from Q0, we still need transition with 1. It should still be Q0. And for this one, Q0 as well, Q1, it should still be at Q1. And for this one, it should move here. And for this one, it should be like this. Right? Yes. Okay, so this is number 6. And number 7. Number 7 doesn't contain. It is the opposite of number 6. So this one is contained. What about the opposite? Doesn't contain. What should we do? How many states? Okay, doesn't contain. It means that it doesn't have O11 as its substring. Let's say that this is L6 and this is L7. So it means that L7 is equal to H stars minus L6, right?
So we can just change the final state. Can we just do that? Like, it's the same as before, but the final state is Q0, Q1, and Q2 instead.
Yeah, that is the way to do it. Okay, so this is also a just so we can copy from number 6. Q0, Q1, Q2, and Q3. So this is start state. This is 1, 0, 1, 1. This one 0, this one 0, and this one 0, 1. Okay, yeah. So we can just change like from number 6, like normal states to be final states, and final states to be normal state instead. So we have 3 final state: Q0, Q1, and Q2. And now Q3 becomes, it is not a final state anymore. You can see that in this case, Q3 now becomes like the rejecting state, right? You can see that when it arrives at Q3, it means that it in our string, it contains 011. So no matter how many symbols that we add to the string, it is still rejected. You see the definition of Q3 here. And when it hasn't arrived at Q3 yet, it means that it hasn't contained the sequence 011 yet. So it means that it is the definition of language number 7. Okay. All right. The last one, number 8. So here you can see the union operation. We have two languages actually, this one and this one.
Cuma anang intersection đó là cô become lang le one union.
Oh, right. Yes, it is intersection. Sorry. So intersection. So it must be a string belonging to this one and also this one. Okay. So what can we do for this one? Okay.
I think we can have 4 states.
Yes, 4 states. So we have W contains AA intersect with W such that W contains BB. Okay, so 4 states. 1, 2, 3, 4. What should we do next? Or like what is the meaning of each state here? This one intersections, so I'm not new yet. What can we do for this one?
I think it needs 6 states. I mean, how I do it, it needs 6 states, but I don't know if it can be optimized for a better solution.
Okay, if 6, what is the meaning of each state? So what is your idea behind the 6 states? Why 6 states? Why is it 6 states? Okay.
I don't know how to explain it. I just do it. I think it worked, but I'm not sure if we can optimize it.
Okay, yeah. So maybe I can show you another technique, because you can see here that this is an intersection between two small languages. So we can, for this, we can create two DFAs, one for each language. So let's say this one is L1 and this one is L2. So it means that L is equal to L1 intersect with L2, right? So let's try to define a DFA for L1 first. So for L1, yes, we can focus on this sequence. So we should have 3 states, right? Okay, let's say this Q0, Q1, Q2. So this one, it is A, and if it is B, it moves here, and here it is AB. Right? This is for L1. And for L2, it should be very similar with 3 states as well. Sorry. But this one should be BB instead. This one A, and this one A as well. Let's call it P0, P1, and P2.
But sir, I think we can do in four states still.
In 4 states, how?
Yes, in 4 states. So what I did is I start with from Q0 to Q1, we should have A, and then Q1 to Q3, we have A.
And this one A.
Yes. And then from Q0 to Q2, I have B. And from Q2 to Q3, I have B. Yes. And so if in Q2 we have A, we go to Q1. And if in Q1 we got B, we go to Q2. So as long as we don't have the, and then in Q3, we go back to, okay, if we have A, we go to Q1, and if we have B, we go to Q2. And I think it's work, but I'm not sure, but I think.
Okay, so this one, 2, 2, 2, 2, 2, 2. Okay, so which one is the final state?
So Q3 is the final state.
Q3 is final state, and Q0 is the start state. Okay. Okay, so let's try with okay, so A, actually, let's say W is equal to AA. It is a substitute, right?
Yes, exactly. But I wanted to do something like it repeats. I mean, after the Q3, we got another A or B, and then we so it repeats. I mean, we don't have. Okay, no, no, sorry, it doesn't work. Sorry,
I think it might work probably if it is union.
Yes, exactly. Union is it working? Yeah.
but I'm not sure as well. We have to try to test all of the cases. But for intersection, it doesn't work because here AA it is a substitute as well. Because for intersection, it should contain both AA and BB, right?
Yes, exactly.
Yeah. Okay. So maybe we can try my technique. Okay, so the technique is that we have to define separately the DFA for each of the small languages. And then we can merge it together later. So you can see that in order to merge these two DFAs together, we can just combine all states from language 1 with all states from language 2. So how many to become a pair? So how many different pairs that we can have?
Can you ask again, teacher? I didn't
So
listen.
in order to merge these two, we want to have only one final DFA, right? But now we have two DFAs. So we can merge these two together. And in order to merge it, we can just create pairs. So in each pair, we have one state from L1 and another state from L2. So I want to know like how many different pairs that we can have. For example, we pair Q0 with P0. So we count as one pair. And then Q0 with P1, this is another pair. So how many pairs do we have? How many different pairs?
Nine then.
Yes, 9 pairs, 9 different pairs, right? So maybe I can, or let's say, or. When I write or I j, it means that it is equivalent to pair qi pj. Okay, so we can use this as our new states. So we will draw here. Okay, so we have two symbols, A and B, and we have 9 different pairs, right? So we have or 0, 1, or 0, no, or 0, 0, or 0, 1, or 0, 2. And then we have or 1, 0, or 1, 1, or 1, 2. And then the last 3 are 2, 0, or 2, 1, and or 2, 2. Okay, so in total 9. We have 9. So what is the transition? For example, all 0, 0. When it reads B, when it reads A, what is the output? Really, we can just look at the transition of each the individual state in the pair. So let's say all 0, 0, it is equivalent to Q0, P0, right? So when it reads A, so Q0 reads A, what is the output?
Q1.
Yes, Q1. So this is Q1.
P0.
And P0, when it reads A, it is P0, right? So we can conclude that or 0, 0. When it did A, it outputs or 1, 0. Okay. So we can put here or 1, 0. What about this one? It is or
0, 1.
yes. We look at yes Q0 1 no Q0B. It is Q0, so R0, and P0B, it moves to 1, so R1. Okay, so we can do this for all of the new states. So we can fill out all of this. So now we can have like the final DFA with 9 different states, and we have all of the transitions. Okay. Now what we have left is the start state. What is the start state? It is very logical. What can you like? Which of the state is the start state? You can see that Q0 is the start state of L1 and P0 is the start state of L2. Of course, the pair Q0 P0 is the start state of our new DFA. So this is the start state. And final state. Which one is the final state, or which ones are the final states? How many final states for this one? So this is important because we have to look at the operations. So this is the intersection operations. Okay, so it means that like the string should satisfy both the condition of L1 and L2. So it means that it should arrive at both the final state of L1 and the final state of L2, right? So we have Q2 here is the final state of L1, and P2 is the final state of L2. So we have to arrive at both of them. So which of the state represent both of them? It is R22, right? So we have only one final state, which is the R22. All right. Is it okay? Is it clear? So what if we change the intersection operations to union instead?
Just L1 or L2 is enough.
Yes. So if it is union, it means that it can either be a string of L1 or a string of L2. Right? So what should we change in our merging of the two DFAs? So we can still do the same thing. We create like a 9 new states, which is represent the pair, different pairs of L1 and L2 of the states from L1 and L2, and the difference is just the final states. Because for intersection, we need to arrive at both Q2 and P2. But for union, it can be either one, or it can be both as well. So what can be the final state if it is a union instead? So maybe I can use different colors. So yeah, so we talk about union, red color.
So
everything is still the same. Yes. So any pair that contain the final state is the final state as well, right? So it should be R22, and then R21, R20, R12, R02. Okay, so we have 5 final states. Okay. Yes, and you can use this technique not just to combine like 2 languages. It can be 3, 4, 5, 6, 7 languages. But instead of creating pair, let's say that if we combine 3 languages, we have to have like 3 tuple. So we have to find all of the possible different 3 tuples that we can create from the states of L1, L2, and the third language, L3. Okay. All right. So I think it is all. So any questions? Is it clear? No question? Okay, if there's no question, yes, I will give you one more exercise so that you can try to do it at home. So number 9. So this one is a hard one, so you can try to think about it. It's a set of string that the string is a binary number. Divisible by 5. Okay, so let's try to do it. So you can see that this is a binary number, so the alphabet, it should have only 2 symbols, 0 and 1. So it means that, let's say W is equal to 10010. So it is in base 2, right? Because it is a binary number. So to know that it is divisible by 5 or not, so you can convert it to like base 10. So what is the base 10 of this one? So this is 2 to the power of 0. Or maybe I can just... Okay, so this is 0, 1, 2, 3, 4. So it is equal to 2 to the power of 4 plus 2 to the power of 1, right? So 16 plus 2, 18, right? 18. So 18 is not divisible by 5, so this one is rejected. And if it is divisible by 5, we can accept it.
លោកគ្រូ
Okay,
ដល់ពេល
yeah.
ចឹងវាអាចជា string ច្រើនប៉ុន្តែវាអាចនឹងអត់មាន pattern ឧទាហរណ៍លេខដែលចែកដាច់នឹងលេខ15វាអាចមានច្រើនដល់រាប់លានលេខចឹងទៅដល់ពេលអារាប់លានហ្នឹងយើងបំលែងទៅជា binary វាទៅជាអត់មាន pattern អីអាចនឹងដូចអាមុនណា
Yeah, no, anh đang cái ta chỉ challenging part với we must have pattern này bạn dânអាច solve ហ្នឹងបានចឹងអាហ្នឹងយើងអាចគិតមើលសិនទៅ so you have to find the pattern, you have to find the number of possibilities for this for this last exercise. So yes, according to you, how many states should we have for this one? Okay, so the thing that you should focus on is divisible by 5 here. So this is the division, right? So how many possibility when we do the division and we look at the, what can we say? How do we call it in English? Some null.
Remainder.
Yes, the remainder, how many possible remainder? How many possible
5.
cases of the, yes?
4.
Is it 5 or 4?
No, I'm not talking about state. If you're talking about remain, I think it's should 4.
Yeah.
4. So we have, it can be, if it is divisible by 5, so the remainder is 0, right?
0, yes.
And then it can be 1, it can be 2, it can be 3, it can be 4, it can be 4 as well, right? So how many different remainders? So we have 5 possible remainders, right? Yes.
Oh,
so
okay.
for this exercise, you can also create 5 different states to represent each of these possibilities. And then what is the final state? The final state is the state that represents when the remainder is 0, or when like the number is divisible by 5. So let's say that you have Q0, Q1, Q2, Q3, and Q4. So you can choose Q0 to be the final state. Okay, so yes, you can try to think about it first, and then yeah, tomorrow we can discuss about it. And tomorrow we will get into a new lesson. So you can see here that for DFA, you will see it again in like, because we have one technique called hidden Markov model. Have you ever heard about it? HMM.
No.
Okay, hidden Markov model. So we will see about this model in the future lessons, and you will see that this one we will use the DFA. It's just that for each transition, we also apply probability on the transition. Okay, so for hidden Markov model, it is also a system which is composed of many states, and to transition from one state to another, we have like a probability. You will see, and especially we use this in NLP. We use this for part of speech. Part of speech tagging. Okay, we used in this application. We will see about that in the future lessons. Okay. So right now, let's just focus on the last exercise here, and tomorrow we will get into a new lesson about text processing. Okay. So any final questions about this lesson number 1?
no
លោកគ្រូខ្ញុំមានបញ្ហាឧទាហរណ៍ខ្ញុំ build DFA ហើយចឹងតែខ្ញុំអត់ដឹងថាធ្វើម៉េចអត់ដឹងថា DFA ខ្ញុំaccept ត្រូវអត់ទេចឹងលោកគ្រូជួយបញ្យល់ធ្វើម៉េចយើងអាហ្នឹងយើងលើកជា case ខ្លួនយើងមកថែមដើម្បី
Yes.
Okay, good.
In order to know if the DFA is correct or not, you have to try to test it with different cases. I don't really have like an automatic way in order to find out if it is correct or not. You have to try to test with different cases. If it yes, if it is good for all cases, it means that it is correct. If you can find some cases that your DFA cannot, let's say that the string should be accepted, but your DFA does not accept the string, it means that it is not correct. Okay. Is it okay?
Yes. Okay. Maybe I have to try do more exercise.
Okay. Yeah. So all right. So if you don't have any more questions, yes, we can end the session right now, and see you tomorrow.
But see you.
thank you
See you.
teacher
Yeah.